Hi everyone, today we're going to look at another example on how to solve using Fourier Transform. Okay, let's straight to the examples. The example is find the Fourier Transform of 1 over x squared plus x plus 1. Okay, so how to find this? So this is what we're going to do. Now we know by the Fourier Transform definition or from the Fourier Transform table, f of 1 over x squared plus a squared is given by pi over a e negative a omega. Okay, so this is the closest from the table that we can use. Okay, although this is not quite look at that, we need to change that. So the first step we need to do is to change this by completing square. Okay, we know that by completing square, x squared plus x plus 1. What do we get? We have x squared plus x equals to minus 1. Now this is 1, so we have 1 over 2 squared minus 1 plus 1 over 2 squared. Okay, now simplifying, now this will give me x plus half squared equals to negative 3 over 4 from here. So we have x plus half squared plus 3 over 4. Okay, so we have close to that. We have close to that now. This is my x squared. Okay, so what we have here, we have next step we want to do is we want to find the Fourier of 1 over x squared plus my a. This is my x, the whole thing. This is my a squared. Okay, so if a squared is 3 over 4, my a is plus minus square root 3 over 2. Okay, so I'm gonna write this as square root 3 over 2. Okay, so by the definition, what we should get, using this definition now, we have pi over square root 3 over 2 e negative square root 3 over 2 omega. Okay, I hope you're with me. Now, if you look at that, now we need to use a translation, Fourier translation formula to change this one, because we have x plus half, not x squared. Okay, so what you do here, we know the Fourier of f a plus b, f a x plus b is given by 1 over a e I b omega over a f at omega over a. Okay, now what we want to find is our Fourier of f of x plus half. Okay, so that means my a is 1, my b is half. This will give me 1, okay, 1 over 1 a I b over 2 omega. Okay, b is half, so 1 over 2, so give me I omega over 2 f hat omega over 1, so which is e I omega over 2 f at omega. Okay, now what is f hat omega? Okay, f hat omega is the one we have obtained here. So Fourier transform of this will give me f hat omega, which is this thing. Therefore, what we have here, Fourier transform of 1 over x squared plus x plus 1 is given by e I omega over 2 f of omega, which is pi over 2 pi over square root 3 over 2 e negative square root 3 over 2 omega. Okay, so simplifying this will give me 2 pi over square root 3 e I omega over 2 e negative square root 3 over 2 omega. There you go. Okay, so this is how you solve the given question. Okay, let's look at another example. Okay, another example is similar to that, taken from your book. Okay, another example will be find the Fourier transform of 1 over omega x squared. That's x squared plus 4x plus 13. Okay, so we want to find Fourier transform. Okay, similar to the previous example. Now we want to find the completing square of by the completing square of x squared plus 4x plus 13. Now what do we have? We have x squared plus 4x plus 4 over 2 squared plus 13 minus 4 over 2 squared. So I have x squared plus 4x plus 2 squared plus 13 minus 2 squared. X plus 2 squared plus 9. Okay, this is what we obtain by completing the square. Now we know the definition of Fourier transform. The definition of Fourier transform from 1 over x squared plus a squared is given by pi over a e negative a omega. Okay, now if you look at here, we want to assume now this whole thing is my x squared, this is my a squared. Okay, so what do we had by using the definition? Fourier of 1 over x squared plus 9, sorry, it's not 9, it's 3, okay, 3 squared, which means my a is 3, I have pi over 3 e negative 3 omega. Okay, this is good. Now we need to use, now we want to change back. So what is this? This is my f hat omega. Okay, now what we want to use the translation formula. Fourier of f ax plus b is given by 1 over a e I omega b over a f at omega over a. Okay, what translation we want to make now is this one, x plus 2. So Fourier of f x plus 2, which means my a is 1, b is 2, is given by a is 1, so 1 e I omega, b is 2 over 1 f at omega. A is 1. Okay, what is f hat? So f hat is whatever we are obtained here. Right? So therefore, I can say that Fourier transform of 1 over x squared plus 4x plus 13 is given by ei omega 2 f at omega, which is ei omega 2 pi over 3 e negative 3 omega. Okay, so you can't simplify this, but I can take out the pi over 3 term, so we have ei omega. Normally you will write like this, okay? 2i omega e minus 3 omega. Okay, that's all for today. So show you more example in my next video.